The person is standing on the edge of a circular platform which is moving with constant angular speed. Put an axis passing through the center perpendicular to the platform. The person is moving along the radius towards the axis of rotation, then the angular velocity will. Well, it's again a very conceptual problem.
Yes.
For those of you who are finding it difficult to understand. Yes, Aniket, what is the answer?
Yes, sir.
What is the answer?
Decreases, sir.
The angular, if the person is moving along the radius towards the rotation, so if this person is moving towards it,
Increase option, sir. Increase.
so what happens? The moment of inertia will decrease. And therefore the angular momentum will, angular velocity will increase. Correct? Hello?
Yes, sir. Yes, sir.
Which is this problem number 39C, right? Okay, I hope all of you understood this.
Yes.
Nothing on this with the hand reaches the other end after moving along the diameter, the angular velocity of the disc will. We have a similar problem with a slight difference. That the hand is here and it is going to move like this and come to the other end. Okay, so what happens?
Yes, sir.
The angular velocity first increase and then it will decrease.
Yes, sir.
Understand? The angular momentum will first it will increase and then decrease. I suppose all of you know what is the reason. If you want to know the reason, you can ask me. I will let you know. Okay, I'm sure. Shall I proceed?
Yes, sir.
The picture is this diagram is given in your textbooks, isn't it? So somebody is on a rotating platform. He is holding two dumbbells in his hand. A boy is having two dumbbells in his hand and is on a rotating platform, right? And the platform is rotating, right? And then it is rotating with some angular velocity, and then he does like this. Then what happens? The speed of rotation will decrease.
Yes.
And again he brings it here, the speed will increase automatically, right? I suppose all of you know this. So what happened here? The moment of inertia increased, right? No external torque or force is acting. It's all internal, right? The hand is applying force to this and this is applying force to the hand. So it is internal forces. Okay? So no external torque, no external force. So therefore, what happens? The moment of inertia will increase, omega will decrease, omega of the rotation. And now again it will increase, right? So this is how, some people dance, no? Right? They spiral around. So they keep the arms like this, ballet dance. And they bring it here. It will become, the moment of inertia will change. So what happens? The kinetic of the system. So the combined moment of inertia is 1 kg. The boy stretches his arms. So if he stretches his arms, it becomes 2. Right? And therefore what happens? The kinetic energy. Now here they are asking about kinetic energy. So initial momentum and initial moment of inertia, final moment of inertia. Okay, so these are the things. So initial angular velocity, final angular velocity. So this is equal to this, right? But here what you have to see is the IF is because he is stretching his hands, isn't it? IF is greater than IA. Hello? Correct? So obviously, omega F will be less than omega I. So that is our conclusion from this. Now they are asking kinetic energy. The kinetic energy of the system in the latter case. Okay. So initial kinetic energy will be what? Half Ia into omega I square, and this will be equal to not equal to. Okay. This is the initial kinetic energy. Don't say equal to. And the final kinetic energy will be half IF omega I square. Hello? Omega F square. Right? So they are asking you whether this will, the kinetic energy of the system will increase or decrease. So take the ratio of 2. Best thing is take the ratio of the 2. So you will write here IF omega F square. So the halves will cancel, and here you see II to IF. IF they are told is twice. So II to IF you will get 1/2. and you have here the omega I and omega f. What will happen to omega I and omega f? So omega f will be
Less than
omega f will be
less than omega.
less than omega, but here they are giving you the figures. They are
Half
giving you the
omega.
figures, isn't it? So if this is
The ratio is less than 1, so kinetic energy.
okay. You want to
Yes,
take
sir.
it. So kinetic energy will decrease.
Yes, sir.
Now, some of you are keeping quiet there. So if you did, I hope you understood. Hello.
Yes, sir. Yes, sir.
So here the other way to simply solve this would be the kinetic energy of this and this. Well, so here II is IF is greater than this, so you get here these two will be 1 by 2. And what about omega I square by omega f square? Omega f square will be less than omega I, isn't it? So this is less. This quantity is less than this. Numerically, can you write the expression and say, okay, this is less?
Yes, sir.
How? By how much it is? How much it is less? By how much it is less?
It is half of efficiency.
It is half of initial. So here, you see, here I would rather do it like this to get this. So you have here the ratio of the kinetic energies II omega I square upon half IF omega F square. So you see this omega I square you write it as into omega I, this you write it as into omega F. So omega I is equal to omega F. So this whole thing will cancel. So this ratio will simply boil down to omega I upon omega F. Hello. So this will be inverse ratio of IF by IF. Clear?
Yes, sir.
So this will be equal to 2. The ratio will be 2. So omega F will be omega I by half. So therefore, what happens? It will decrease, right? The kinetic energy will decrease.
Yes.
So you see, I just your guess was correct. There is no doubt about it. Your guess was correct. But well, numerically I worked out and got the answer. So this is P. Okay, fine.